Hey everyone, this is your 5.5 Ready Set Go notes. So if you take a look at our learning target for today, it says I can graph a linear inequality given an inequality or situation in context. So the new thing that we're going to be talking about here is exactly what a linear inequality is. In order to do that though, we're going to do a quick review of the inequalities that we did in Module 4. So if we look here, we've got x is less than 2. So hopefully you remember, we're just going to do 1, 2, 3 on our number line. They go right in order. Since this is a less than symbol, it's going to be an open circle. And I want to shade the direction that the numbers are less than 2. So I want smaller than, which means I'm going to shade to the left. Again, this one is a less than symbol. And so we decided to shade to the left and we had an open circle. Remember, a less than looks like an L. If you use your left hand, you can make an L and it looks exactly like that less than symbol. This one here looks very similar, except it's a less than or equal to. So now we're still going to have 1, 2, 3 on our number line. We're still going to have the circle on 2, but this time because it's equal to, it's going to be shaded in. And then we're going to shade to the left. So we have a closed circle anytime it's equal to. And you'll notice for both of these, we shaded to the left because they were both less than symbols. All right, then here we have a x is greater than 2. So we've got 1, 2, 3. You'll notice it doesn't say equal to. That must mean this is an open circle. And I want numbers that are greater than 2. Well, greater than means bigger. And if I look, I know that 3 is bigger than 2. So I'm going to shade to the right. This one is our greater than or equal to symbol. And so we've got our 1, 2, 3. We're going to have a closed circle since it's equal to, and we're going to shade to the right because it's greater than. So again, both of these two were greater than symbols, and we shaded to the right. Both of these two were less than, we shaded to the left. The two without the equal to are the open circle, and the two with the equal to are the closed circles. So open circle is anytime you have a greater than symbol or a less than symbol. All right, so the key for an open circle is that it's not equal to, because we're excluding that specific value. All right, a closed circle happens anytime we have a greater than or equal to or a less than or equal to. By the way, open circle, clearly. Closed circle. There we go. Closed circle happens when we do have the equal to, because we're saying, hey, this value works, you can use it. We shade to the left anytime we want to get smaller. So anytime we use less than symbols, we shade to the left. So that could mean less than or less than or equal to. And if we shade to the right, it means we want to get bigger. And so we're looking at greater than. And so that could be greater than, or it could be greater than or equal to. Hopefully that's a nice quick review for you. Now we're going to be talking about graphing inequalities that have two variables. You'll notice everything we just did in our review only had one because that's all we covered in Module 4. Well, now we're moving on, right? So in order to do this, we have to combine what we know about lines, so a lot of what we just did at the beginning of Module 5, and then inequalities, what we did in Module 4. So let's take a look at what this might be. So you'll notice we've got this inequality here. 3x minus 2y is less than or equal to 8. Hopefully you can look at this and recognize that that's in standard form. But we don't want to graph inequalities when we're in standard form because it can kind of mess us up a little bit. So instead, we're going to follow these 4 steps that we write down here, and we'll always be able to graph correctly then. All right? So the first thing that you're going to do, step 1, is always going to be to isolate the y. And remember, isolate really means get it by itself. So get it alone. So we're going to be kind of looking to get something along the lines of y equals mx plus b. Now, it won't be equals because we'll have an inequality symbol instead, but we need to get the y by itself. All right, so let's take a look at this inequality and let's just go ahead and do that. So in order to isolate the y, we're going to have to solve, which means we're going to use some inverse operations here. So I'm going to draw my line, and the first thing I'm going to do is subtract 3x. Now when I do that, that cancels out the 3x that's on that side, and I'm left with negative 2y. I leave my inequality symbol alone, so less than or equal to, and I'm going to put my negative 3x in the front, and then leave the plus 8 at the end there. So you'll notice I didn't change the negative 2y, the less than or equal to, or the 8. Well, now, in order to keep solving, I'm going to have to divide by negative 2. And so I'm going to divide everything here by negative 2 so that this cancels out, and I'll be left with my y. But now when I look, I have a positive 3 over 2x. I have a negative 4, and there's something else really important that happens here. Anytime we multiply or divide both sides of an inequality by a negative number, which is what we did right here, we have to remember to flip our inequality symbol. So instead of being a less than or equal to, this is now a greater than or equal to symbol. So I want you guys to go back up here and I want you to write yourselves that note. So note, remember to flip the inequality. If you multiply or divide both sides by a negative number. That's something that we have to remember from our work in Module 4. Anytime you're solving an inequality, it's the same as solving an equation, except for this one thing. Multiplying or dividing by a negative number, you have to flip the inequality symbol. So again, we switched from a less than or equal to a greater than or equal to. But now if you look, this is in slope-intercept form, which is good. So that kind of brings us to step 2. Step 2 is going to be identify the slope and the y-intercept. Now remember, the slope is our m value, and the y-intercept is the b, and we always write it as a coordinate point. So we have to write it as 0, comma b. It's going to give us our starting point. So if we take a look at this line here, we see that the slope, the m, is 3 over 2, and the b value is negative 4, which tells us that our starting point is going to be 0, negative 4. Now notice I haven't done anything on the graph yet, and there's a reason for that, all right? So just bear with me for a little bit. Okay, the next step that we have to take care of is we have to determine if the line is solid or dotted. And I'm sure that that sounds a little strange to you because every time we've drawn a line, we've just put some dots and drawn a line through with our ruler, put arrows, and we've moved on. But think about what we did on the last page. On the last page, these inequalities were all different. All the graphs looked a little different because we either had an open or a closed circle, and we either shaded left or right. Well, when we have two variables in our inequality, we can either have a solid line or a dotted line, and then we can either shade above or below. So we have to talk about how to determine that. So if the line Um, or I'm sorry, to determine if the line is solid or dotted, you have to look at the inequality symbol. All right. So if it's equal to, then you're going to have a solid line. So anytime you have less than or equal to or greater than or equal to, you're going to have a solid line. So this is very similar to having that closed circle, right? If it's equal to, then it's a closed circle and it's a solid line. If it's not equal, then you're going to have a dotted line. All right, so if it's either a less than symbol or a greater than symbol, you're going to have a dotted line. So if we take a look at this one, we have a greater than or equal to. So this greater than or equal to, because it's equal, we're going to have a solid line through our points. Okay, and the last thing that we have to do is we have to determine where to shade. So determine if you shade above or below the line. So in order to determine if it was solid or dotted, we looked at, is it equal to or is it not equal to? In order to determine where we shade, we need to look at the actual symbol of the inequality. So we're going to shade above anytime we want to be greater than. Because remember, above means bigger, so does greater than. So if I want to be greater than, I need to look at the numbers that are above it, which means greater than or equal to. And then, let me just draw that through. We're going to shade below anytime we want to be underneath the line. So that's going to be less than. So that could mean less than or equal to. Well, if we look at what we've got, this symbol is greater than or equal to. And if we're greater than, it means we're going to shade above. So now we've figured out what the slope and the starting point is. We've decided it needs to be a solid line, and we've decided that we need to shade above that line. So we're going to go ahead and actually do that. So the slope, or I'm sorry, the starting point is -4. Slope is 3/2. So I'm going to use that slope as much as I can to fill in my graph. I'm going to use my ruler, and I'm going to draw a solid line. With arrows. And we decided that we need to shade above. So we're going to find our y-intercept, and we need to shade above that. So I always like to maybe draw myself little arrows to kind of remind myself. I'm going to shade above, and so I'm just going to shade in this whole area on my coordinate plane. Anything above the line needs to be shaded. Now what that means is anything in this shaded area is a solution to the inequality. So I can pick anything that's in this area or on this line, and it would make this inequality true. All right, so just as a quick recap, we're going to have a solid line if it's equal to. So if your symbol is less than or equal to or greater than or equal to. You're going to have a solid line. And so a solid line just means you're literally going to connect the dots and draw your arrows. A dotted line is used when it's not equal to. And so that would mean a less than or a greater than symbol. And what that would mean is we would literally have to draw a dotted line and put arrows instead. We're going to shade above anytime we use a greater than symbol. So that could mean greater than or greater than or equal to, because above means we want to be bigger, and then shade below means we want to be smaller, so that's less than. So it could mean a less than symbol or a less than or equal to symbol. All right, if we shade above, let's say our line was here, shading above would mean going above the line. And then shading below, let's say our line was here, that would mean anything below that line would be a solution. Okay, we're going to do a couple more examples because I know that that was a little weird. So we're going to do number 1 over here. And we luck out, number 1 is already in slope-intercept form. The y is already isolated. So we get to go ahead and skip step 1, which is kind of nice. All right, step 2 says identify the slope and the y-intercept. So our slope is going to be 4. The b value is -3, and so our starting point is going to be -3. Determine if the line is solid or dotted. Well, we have a greater than symbol. It's not equal to. And so this must be a dotted line. Okay. And then we need to determine where we're going to shade. So if we have a greater than symbol, greater than means above. So now we're going to use all this information to actually graph our inequality. So we're going to start at 0, -3, which is right here. Our slope is 4, so up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 2, 3, can't go any more that way. 1, 2, 3 over 1. So you'll notice there are 4 dots that are on this inequality, on this line right now, right? I didn't count that right. 1, 2, 3, 4 over 1. Sorry about that, not that one right there. So I'm going to use my ruler, and what I'm going to do is instead of drawing a solid line through it, I'm going to draw a dotted line. So I'm just going to kind of connect the dots, but not totally connect them, and then I draw an arrow on either side to show that it does go on for forever. All right, and then this is a greater than symbol, so we're going to shade above, and so I'm going to shade anything in this region above the line. Again, what that means then is anything that's in this shaded region is a solution to the inequality. All right, for number 2, the y is isolated, which is a good thing. But in order to determine, or actually, we can just find the point and the slope. We don't have to do anything here. So instead of finding the y-intercept, we're going to just use, because this is in point slope form, we can use our starting point. So our slope is going to be 3, and our starting point is going to be -1, -2. Now, if you want, you can determine the 3 and combine like terms to find your y-intercept, and that would be totally acceptable. So our starting point is -1, -2, which is right here. And we have a slope of 3, so up 1, 2, 3 over 1. 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 Now I got a little bit ahead of myself. I didn't actually identify whether I'm going to shade above or below and whether it's a solid or dotted line, right? So I have a greater than or equal to symbol. So because it's equal to, I know that I'm going to have a solid line. All right, and then I also need to look at the symbol to decide where I'm going to shade. So greater than or equal to, the fact that it's greater than means that I'm going to shade above. So I'm going to use my ruler. I'm going to draw a solid line through my points. And then I'm going to shade above. All right. I know this video is getting a little long, but I do want to do one more example with you guys just to make sure that you really understand what's going on because I know that this is a weird thing that we're doing. So bear with me. Watch this one last problem. So 2x plus 2y is less than 10. In order to do this, I have to follow my steps, right? And my first step says to isolate the y. So the first thing I'm going to do is subtract 2x from both sides. And I get 2y is less than negative 2x plus 10. And then I'm going to need to divide everything by 2. So I'm going to have y. I'm going to get a negative 1x plus 5. And now I did not multiply or divide by a negative number, so I am not going to flip my inequality symbol. So here is my new inequality that I'm going to graph, and it's in slope-intercept form. So my slope is going to be negative 1. My y-intercept is 5, so my starting point is 0, 5. So I'm going to start here, and a slope of negative 1 means down 1 over 1. So I can just fill this in right away. And I can go the other direction, also up 1 and left 1 to fill in that whole thing. All right, now I'm going to look at whether it's going to be a solid line or a dotted line. Well, I have a less than symbol, which is not equal to. So if it's not equal to, this is going to be a dotted line. So I'm going to use my ruler and line it up. And instead of just connecting it all at once, I'm just going to put a couple of lines through it and connect that way. And then draw my arrows. Okay. And then the last thing I need to do is determine where I'm going to shade. So I have a less than symbol. And since it's less than, I'm going to shade below. And so that means here's my line. I want to shade below that line, which means I'm going to shade this direction. To help me determine the way I'm going to shade, by the way, I find my y-intercept. So my y-intercept was right here, and I want to go underneath that since I'm less than. All right, again, I know that this video was a little bit longer, but this is all you had to do for your assignment for today. Later this week, you guys will get some practice to try and work through some on your own. So if you have any questions, please reach out to me before then. All right, thanks for watching. I miss you guys.